Hi everyone, so my name is Varun Ahuja. I just completed my studies at Quantities Polytechnic University, which is known as KPU in Surrey, British Columbia, and in operations and supply chain. I thought about making YouTube videos and sharing my concepts that I learned during my studies in operations and supply chain. So this is one of the example that I got to know the transshipment problem. So I would be explaining this further. We have the customers, we have the distribution center, we have the bakery. So bakery is the manufacturer, then it goes to the distribution center, then it goes to the customers. So we need to optimize the transfer with the quantities that is we need to require in our demand and maintaining our distribution capacity and bakery capacity. So let's talk about the transshipment problem that we have is here. We have the distribution center, we have the bakery, we have the customer. The customers is mentioned here like Bridgewater. These are the locations of the customers that we get, and we have the demand of the customers at these locations. And we have the distribution center here. So distribution center and the capacity of the distribution center. And we have the bakery and the bakery's location. We have three bakeries and three distribution center. So let's find it out what is the best possible solution to minimize the cost for this transshipment problem. So we have the three of the bakeries, and this is the inbound transport. The inbound transport is from the bakery to the distribution center. So these are the distribution center, three of us. So I will just copy this, and the distances are there. So distance between Cross Keys and Dayton is 9 miles, and from Harrisonburg to Dayton is 5 miles, and from Mount Crayford Dayton is 5 miles. So I will just copy this to mention about the quantity. So this table I've just pasted it here. I use the Control C plus Control V function and just pasted these details. I will just select this. I will type 1 as the quantity and will type Control Enter. So this will all changes is to 1. 1 is the quantity for every location we are moving from distribution center from bakery to the distribution center. So what are the total quantities that is in the bakery? I can just select these cells, these three, and press Alt equal. So I will get the total number of quantities that has been moved from bakery. So what are the total quantities that has been in the distribution center? I will just select this cells, will press Alt equal. So this is the solution that you get it here, right? And then we jump for the outbound transport that's from the distribution center to the customers. So I will just copy this, Control C. I will just paste it here, Control V. Now I will also change this into quantities. So these are the distances which is mentioned on the left side, and right side are the quantities. So the quantity changes and the cost price also, the total price also changes according to that, the total cost I mean. So if I type 1, I will just select this first as I did before. We'll type 1 and use Control Enter key. So this all equals to 1. So 1 is the quantity from every location, from every distribution center to every customer. So this will change when we use the formula, when we use the solver model. So, I will just select this cell and will type Alt equal. So I will get an auto sum formula. So this is auto sum formula you can see in the formula bar. Now I jump to the bottom side of it, which is the horizontal row, last row of this section. And I will just select this and will type Alt equal. So this is here, right? So you get it here. Now I will just check it out. What are the distribution centers? So these are the three distribution center. So I will just copy this distribution centers and the capacity of it and will just paste it here. When I paste it, I will do a transpose. So I will click a transpose. And I just click it here and you get the transpose paste. So these are the capacity of the distribution center. Now What is the conservation flow? The conservation flow is like the number of units that's been moving from the bakery to the distribution center, and then from distribution center to the customers. So this is the same in every business. You have like Walmart, Costco. So Costco is a retail retail outlet, and they get the products from different distribution centers, and they might have their own distribution centers to store all the products so they can manage their own capacity. So in Costco also, like they have like they optimize their transportation channel and transportation and quantities also, so that they can have the minimum cost, and they further they can reduce the cost, and they would be able to deliver the products in the minimum cost to the customers. So what is the inbound flow? The inbound flow is the same quantity which is coming from the distribution center. So from the bakery to the distribution center. So I'll just select this, enter. So these are the quantities. What is the outbound flow? So outbound flow is the same quantity that has been delivered to the customer. So this should be equal. Means the customer the quantity that we are receiving from the bakery to the distribution center should be equal to the quantity that has been delivered to the customer. So I will just select this and will control enter. So this is equal. Here I just want to put the equal sign. I don't want to put the formula. So I will just type this and equal. So you get the equal sign. I will just drag this now. So I'll just paste this. So you get the same formula, same here. So inbound, this should be this shell, the three number in the inbound row if you see. So suppose you have a business, and you have the incoming products from your seller coming up, right? So you are also a seller and he is also a seller, but you should measure inventory and like get the information that your incoming inventory should be equal to the inventory that you have plus the inventory that you have sent. So you calculate your mathematics, and you find out like your inventory should be equal or balanced. If your inventory is not balanced, or you might be missing out some products. So the reasons of missing out of some products because you don't check your inventory in on a regular basis. So that's why, like, to minimize the cost, you need to check your inventory on properly basis, on timely basis, and plan your transportation on the minimum viable cost. So next we jump on to this is the inbound conservation flow. Now we calculate the total cost. So inbound cost is, what is that inbound cost? So we will calculate like this. We use the sum product option and we jump onto this. So what is the inbound cost? So this multiplied by, this multiplied by the quantity. So distance multiplied by quantity. Because on the left side, if you see, that is the distance, on the right side it is the quantity. So you multiply it by these two, bracket close. And what is the cost per mile? The cost per mile is 0.05 for inbound. So I'll just enter. So this is the inbound cost. So I'll just mark this as yellow because it will change when you run the solver mode. So I'll just turn this yellow, and we'll just turn this as well yellow. So when this change, you would be able to see the quantities that you want to deliver. Now jumping on the outbound cost. So outbound cost would be some product distance. Where is the distance? From outbound distance. Outbound distance is this. So we select this, comma, and we select the close keys, the quantities that we are having from distribution center to the customers. So I will select the quantities here. And what is the outbound cost per mile? You just check it out. That is in the cell 36. See, it's C36. So I'll just multiply it by C36. So you see, like, so this is the total cost that if you are delivering one quantity from single quantity, not the number of their not number of products we have taken as one right now. So you would be able to solve it with the help of the solver model. So now everything is done. We got the total cost, we got the conservation flow, we got the quantities. Now we will check it out the solver model. So we go to the data and click on the solver model. What do we want to minimize? So we have already done that, so that's why it's show here. I will just delete this so that you guys can understand. So we want to minimize the cost. What do we want to minimize? We want to minimize the total cost. I will just jump on to the minimize the total cost. So this is the total cost. I will just select this, and we want to minimize by changing what? We want to change the unit of the inbound transport and the unit of the outbound transport. Let's see. So we are going to change this, and now we want to add the variables, the constraints. So I can add the constraints by doing this. So this, the quantity should always be an integer. So I will just select this. This should be integer. Add this. So the next one, this quantity, the inbound quantity will always should be an integer. So I will add this. Now the conservation flow, the outbound quantity should be equal to inbound quantity. So this should be equal to the outbound quantity, outbound transport. So this is added. Now we jump on to the next one. So this quantity from the bakery should be less than equal to the bakery capacity. What is the bakery capacity? Should be this one. What is the bakery capacity? The bakery capacity is this. So bakery capacity is this. I will just add this again because I'm just messing up with the formula. Excel always you need to check the formula. So I will just selecting this. So this is added. Next we have the distribution center capacity. So distribution center capacity, this should be less than equal to the distribution center capacity, which is no. So which is I will just add distribution center capacity here. How many constraints we have added? So we have already added 5 constraints. Now we can click on the, we need to select simpler linear progression formula. We don't need to go to the non-linear one. So we'll just select the simplest non-linear progression formula and just click on solve. So when you click on solve, you will get here the answers. Oh, something is wrong. What is wrong? That we don't know. One thing is wrong. Now I get it. Now I go to the solver model. If you check it out, we have mentioned the integer as the quantity bought. We have mentioned the capacity of the distribution center and the bakery, and we have also mentioned the conservation flow. What one thing is pending? Guess what it is? It is demand. So the total demand should be equal to the demand that has been raised by the customers. So I will just add the one more constraint. Go to this. This is the outbound transport. This should be equal to the total demand. What is the total demand? So I'll just select this. I'll just add OK. Now I solve it. Here you see we get the number that we want. So we get the number, which is the total cost, and the capacity. You see the inbound number and outbound number is matching with each other. So you, when you do this, you will face issue. I'm sure. I'm 100% sure. But when you do this two or one or even more than one time, and you need to find a solution. If you don't find a solution, just check out the errors that you are getting. So I checked the errors that I did not. I forgot to mention the demand. So the demand should be equals to. So you see this demand is the same number. You get it here. So this is also equal. This is equal to this. So that's why I mentioned last time. Even I had done this 2 3 times. So that's why I get used to it. Otherwise, it's very difficult for me as well, right? So you guys are good, and you guys can practice this. I'll attach the Excel file, and you can get the data. So after you get the data, you can do this. Now, one more thing I want to mention is you can change the details. You can change the details in the solver. You can take out a report. How do you take out a report? I will explain in the next video. Thank you so much, guys. You can do a trans. So you find out a solution like how many quantities that you need to transfer from every distribution center to the customer, and you got a solution that how many quantities that you need to supply from bakery to this distribution center. So from Dayton, you only need to supply to Mount Greyford, which is 50 units. So no need to worry about that. Thank you so much, guys. It's nice connecting with you. Just enjoy the session and have fun. Thank you.